Alright, so here we have 5.4, the sum and difference formulas. We're going to go through a whole lot of formulas that allow you to rewrite an angle using sum or difference formula for a certain function, either sine, cosine, or tangent. Alright, let's go ahead and get started. Alright, so here we have the sum and difference formula for the sine function. So if you have the sine of u plus v, which is the sum of two different angles, then it's the sine of u times the cosine of v plus the sine of v times the cosine of u. And if you have the difference of those two angles, then we have the sine of u times the cosine of v minus. So the nice part here is the formula is pretty much the same. When you're adding, you're going to add the two different sides together, and if you're going to subtract, you would then subtract the two sides. And the reason why this is convenient or helpful is because sometimes we have an angle that is not on a unit circle, but it could be the sum or the difference of two angles that are on the unit circle, and we could then use these formulas to evaluate that trig function at that specific angle. So let's go ahead and give it a shot. Alright, so for our first example, we have the sine of 315 minus 60. Now if I actually subtracted 60 from 315, then I would get the angle of 255. And that is an angle that is not on a unit circle, so I can't evaluate that. But by using our difference formula, we can. Okay, so let's go ahead and plug in our values. For the sine of 315 degrees, we have negative radical 2 over 2. And then for the cosine of 60, we have 1/2. Then we're going to subtract the square root of 3 over 2 times the square root of 2 over 2. When we simplify this, we get negative radical 2 over 4 minus radical 6 over 4, which means our answer is negative radical 2 minus radical 6 all over 4. And now we have an expression for the sine of 255 degrees. Alright, for our next example, we have the sum formula. And again, if I were to add 2 pi over 3 and 3 pi over 4, then I get 17 over 12, or 17 pi over 12, which is again something that is not on a unit circle. So we're going to expand it using our sum formula, and then plug in what we know. The sine of 2 pi over 3 is going to be radical 3 over 2. Then we have times a negative radical 2 over 2 plus radical 2 over 2 times a negative 1/2. And that's what we get when we evaluate each one of our trig functions here. Okay, now we're going to go ahead and multiply to simplify this. So we get the square root of 6, negative square root of 6 minus the square root of 2, and they are all over 4. And that's our answer. So the sine of 2 pi over 3 plus 3 pi over 4 is negative radical 6 minus radical 2 over 4. Alright, so I want you guys to go ahead and think for a second. We have the sine of 75 degrees, and we need to split that up into two different angles that either add to or subtract to be 75. And there's a lot of different ways. So hit pause now and try and think of two angles that either add or subtract to be 75. Alright, so I'm not sure what you came up with, but I came up with 30 plus 45. Okay, so now we're going to go ahead and split up the sine of 75 to be the sine of 30 plus 45. Using the sum formula, it's going to be the sine of 30 times the cosine of the other angle, 45, plus the sine of 45 times the cosine of 30. Okay, now we're going to plug in our values. So we have the sine of 30, which is 1/2. The cosine of 45 is radical 2 over 2, plus the sine of 45, which is radical 2 over 2, times the cosine of 30, which is radical 3 over 2. When we simplify this, we get radical 2 plus radical 6 over 4. And then we have something for the sine of 75 degrees. Okay, here we have the sum and difference formulas for the cosine function. The nice part about these equations is it's cosine of both angles minus sine of both angles. And notice that is for the sum. So when you're adding two angles together and you evaluate it, we're going to be subtracting the two things. For the difference, we have the cosine of both angles plus the sine of both angles. So again, just to emphasize, when we are adding the two angles, we're actually going to subtract for our formula. If you're subtracting the two angles, then you're actually going to be adding for the formula. But the next part is, again, we have cosines on one side and then sines on the other side. So this makes it pretty easy to remember. Alright, so here's our first example. We have the cosine of 5 pi over 4 minus pi over 6. So again, since we're subtracting, in our formula we're going to be adding. And we have the cosine of both angles followed by the sine of both angles. Okay, so let's go ahead and evaluate this. Let's see, when we plug these in, we have negative radical 2 over 2 times radical 3 over 2 plus a negative radical 2 over 2 times 1/2. When we simplify, we have negative radical 6 minus radical 2 over 4. And that's what the cosine of the difference of those angles equal. Alright, you guys are up again. So here we have the cosine of 15 degrees. Again, I want you to come up with two angles that either add, or in this case, subtract, to be the cosine of 15 degrees. So hit pause now and think about that. Okay, so I was kind of lazy and I picked two angles in the first quadrant. I have the cosine of 45 minus 30. And that gives me 15. But I could have used 330 and 315. Or I could have used 240 and 225. Both sets of angles are on the unit circle. In this case, though, I kept it easy and went with the first quadrant. So when I expand this, I'm going to have the cosine of both angles. So the cosine of 45 times the cosine of 30. And since I'm subtracting here, I'm going to be adding in my formula to give me the sine of 45 times the sine of 30. Okay, so now we're going to plug things in. And when I plug in my values, I should get radical 2 over 2 times radical 3 over 2 plus radical 2 over 2 times 1/2. And when I simplify all of that, I'm going to get the square root of 6 plus the square root of 2 all over 4. And then we have the cosine of 15 degrees. Alright, and here we have the most tedious and the most complicated formula, the sum and difference of the tangent function. Alright, so one thing that's kind of nice here is when we are finding the sum of two angles, we're going to be adding the two tangents in our numerator and doing the opposite for our denominator. We have 1 minus tangent of u times tangent of v. If, on the other hand, we are subtracting our two angles, we're going to also be subtracting in our numerator, and in your denominator, you're going to be doing, again, the opposite, 1 plus. So when you're adding, the numerator is adding, and your denominator is subtracting. If you're subtracting, then your numerator is subtracting, and your denominator is adding. Hopefully that made sense. Let's go ahead and try it. Okay, so here we have the tangent of 45 degrees minus 30 degrees. Since we're subtracting in our equation, we're going to be subtracting for our numerator. And we're going to go ahead and evaluate these. Alright, so try and stay with me. This gets a little bit complicated. The tangent of 45 is 1. The tangent of 30 degrees is radical 3 over 3. Then we're going to divide that by 1 plus 1 times radical 3 over 3. My 1 in my denominator doesn't really need to be there, so I'm going to get rid of that. And my next step is to combine both my numerator and my denominator into a single fraction instead of two different fractions. And I'm going to do that by multiplying by a common denominator to begin with. So we're going to multiply by 3 over 3 here and 3 over 3 here to get 3 minus radical 3 over 3 and 3 plus radical 3 over 3. But wait, there's still more. Instead of dividing by my fraction, I'm going to multiply by the reciprocal. So we're going to cross this off and multiply by 3 over 3 plus radical 3. My 3's are going to cancel. And I'm now left with 3 minus radical 3 over 3 plus radical 3. To finish solving this, I'm going to multiply by what we call the conjugate, which is 3 minus radical 3 over 3 minus radical 3. And that will give me 12 minus 6 radical 3 over 6, which will simplify to be 2 minus radical 3. So quite complicated and a lot of steps, but in the end we got something that is not terribly difficult. Alright, so here we are at it again. Tangent of 3 pi over 4 plus pi over 6. Again, since we're adding in our equation here, we're going to be adding and then subtracting down here. Let's go ahead and try and evaluate this. So the tangent of 3 pi over 4 is negative 1, and the tangent of pi over 6 is radical 3 over 3. And we're going to be dividing that by 1 minus the tangent of 3 pi over 4, which is a negative 1, and the tangent of pi over 6, which is radical 3 over 3. Alright, so on my denominator minus the negative 1, that's going to go ahead and reduce to be plus, right? My next step is then to get a common denominator, so multiply by 3 over 3 and 3 over 3 to give me negative 3 minus radical 3 over 3, plus. And then we have a 3 plus radical 3 over 3. We don't like to have fractions, so instead of dividing by this fraction, we'll multiply by the reciprocal. Those 3 cancel, and I'm left with negative 3 plus radical 3 over 3 plus radical 3. Okay, so I'm going to rewrite that down here at the bottom. Negative 3 plus radical 3 over 3 plus radical 3. We're going to multiply by, again, our quote-unquote conjugate of our denominator. So we have 3 minus radical 3 over 3 minus radical 3. When we multiply that out, we end up getting negative 12 plus 6 radical 3 over 6, which will simplify to be negative 2 plus radical 3. Again, something that is simple when you think about where we started and how we had to get here. Okay, so now the somewhat easier part. We're going backwards. This is the expansion of the sum or difference of either the sine, cosine, or tangent. Your job is to figure out which one it is. So, since we have sine times cosine plus sine times cosine, and we are adding, that leads me to believe that this is the sum of two angles, the sine of the sum of two angles. So I'm going to go ahead and add those two angles together, which are 110 and 80. And just rewrite that as the sine of 190. Now at this point, if this angle had been on the unit circle, I would expect you to simplify it. But since it is not, that's all we can do, and that's our answer. Alright, this one's pretty much a giveaway because we only have one function that deals with tangents, and that is the sum or difference with the tangent function. Since we are subtracting, that should give away that it's the tangent of the difference of two angles. So we're going to go ahead and subtract our angles, which gives us the tangent of 140 minus 60, which will simplify to be the tangent of 80. Again, if 80 degrees had been something on the unit circle, I'd expect you to simplify that, but since it's not, this is your final answer. Alright, your turn. Look at what's given to you, try and identify which sum or difference formula it is, and then either add or subtract the two angles. Let's go ahead and hit pause now and try that. Alright, so let's see how we did. Now we have cosine times cosine minus sine times sine, so the giveaway is that it's a cosine. Since we are subtracting, remember that means we're going to be doing the opposite with our angles. So it's really the cosine of the sum of two angles, which means you have the cosine of 20 degrees plus 30 degrees, which simplifies to be the cosine of 50 degrees. And since that is not on a unit circle, it is your final answer. Okay, now for some more fun. I'm telling you what the sine of u is and what the cosine of v is, and since these are not on the unit circle, we're going to draw individual triangles for each one. Since the sine is 5 over 13, that tells us that the opposite side is 5, and the hypotenuse is 13. Using the Pythagorean formula, we can get that the adjacent side is 12. Looking at our next triangle, the cosine of v is negative 3 over 5, which means negative 3 is the adjacent side, 5 is the hypotenuse. Using the Pythagorean formula, we would then get that our opposite side is 4. And as a follow-up to this, I could find the cosine of u, which would be the adjacent side over the hypotenuse. And I can also find the sine of v, which is the opposite side of the hypotenuse. And these are really important because as we move forward and I'm using my sum or difference formulas, I need to know both sine and cosine. Like for example right now, when I say find the sine of u minus v. So expanding that formula, we have sine of u times the cosine of v minus sine of v times the cosine of u. And we're going to plug in the actual values. So from the last example, I know that the sine of u is 5 over 13. And the cosine of v is negative 3 over 5. We also found the sine of v to be negative 4 over 5, or sorry, to be 4 over 5. And the cosine of u is 12 over 13. And when we go ahead and multiply these together, we get negative 15 minus 48 over 65, giving us a final answer of negative 63 over 65. So the sine of u minus v is negative 63 over 65. Alright, and here's our last example, again based off of that triangle that we drew 2 slides ago. The cosine of u plus v is the cosine of u times the cosine of v minus the sine of u times the sine of v. We're going to plug in what we know from that triangle. The cosine of u was 12 over 13, and the cosine of v was negative 3 over 5. And then we have positive 5 over 13 for the sine of u, and positive 4 over 5 for our sine of v. When we multiply things together, we get negative 36 minus 20 over 65, which will simplify to be negative 56 over 65. Alright, so that does it for this session of notes. Go ahead and use the formulas which you have on the back of your worksheet to attempt the homework, and good luck.